Hello students, welcome to chapter 13, limits and derivative. Students, today I am going ahead in the last part of this chapter, exercise 13, question number 15. Yes, this is the last part. ddx of cosec x into cot x. Apply into u into v rule. Let's consider is u. That's the v. So first, second derivative. Similarly, now second, first derivative, and just operate formula. So cosec x as it is, cot derivative known very well, minus cosec square x, and here cosec derivative minus cosec into cot. Numerical done. So your final answer is minus cosec cube x, and another is same as students, to minus cosec x into cot square x. Either you will take the common, this is the last answer, but otherwise if you common taking, then also correct. Cosec square x plus cot square x. That much. Question number 15. Now going ahead to 16th one. 16 is IMP for exam level. ddx of cos x by below 1 plus sin x. Very easy. Apply it. Simple. Your division formula in denominator square. Now denominator ddx of numerator minus numerator ddx of denominator, and apply the rule. Simple formula. So 1 plus sin x as it is, students. Here derivative minus sin x, same as here. That will be 1 is 0, the sin derivative is of cos x, and upon as usual 1 plus sin x the whole square. Now expansion. So that's my first expansion is a minus sin x minus sin square x, say minus cos square x, and downwards as it is. I think you know that one of the common value between that here minus 1 common, and other answer is a minus sin x, minus 1 common, remaining sin square x, cos square x, and I am sure you know that that is only 1. So minus sin x minus 1 and 1 plus sin x whole square. Now students, you will take the common only. Minus 1 common, sin x plus 1 upon 1 plus sin x whole square. 1 time gone, remainings are 1 plus sin x. That much your final answer, students. Now continue going ahead. Question number 17. Very interesting numericals, sir. Yes. Question number 17. ddx of, in the 17, sin x plus cos x by sin x minus cos x. This is an IMP question, sir. Sin plus cos, because your trigonometric parts also available in that types of solutions. Sin plus cos, below downwards sin minus cos. Going that your division parts, u by v rule, in the denominator square. Now denominator ddx of numerator, sin plus cos x. It means denominator numerator derivative minus, now numerator denominator derivative ddx of sin x minus cos x. Now start simple way of formula sin x minus cos x. Students, here derivative you know, sin derivative is cos, but cos derivative is a minus sin. Minus, that also same, sin plus cos. And here derivative sin is cos, but minus cos is sin x, and upon as it is sin minus cos the whole square. So here you will take the common, that minus 1 only. It is a perfect square. So here I will take minus common. Another are cos x minus sin x. And here also same, cos x minus sin x is as it is. Actually I will convert this r both in the whole square. This also whole square, students. So sin x plus cos x by, as usual, sin x minus cos x the whole square. In short, that's the whole square value, cos x minus sin x the whole square, these two are. And here whole square expansion, sin x plus cos x the whole square, and downwards is same as sin x minus cos x the whole square. Here you will expand totally and you will get simple trigonometric solutions, students, here. And then after you get the answers. So minus 1 as it is I will show, but another are whole square expansion, which is cos square x minus 2 cos sin x plus sin square x, minus here also same, students, sin square x plus 2 sin x cos x plus cos square x, and downwards as it is sin minus cos the whole square. Now you know very well, this is the identity, cos square plus sin square 1, that is also identity, cos square plus sin square x is 1. So my value is minus 1, 1 minus 2 cos x sin x, minus here also same, 1 plus 2 sin x cos x, and upon as it is. Now just expand minus 1 inside, it is minus 1 plus 2 cos sin, say minus 1 minus 2 sin cos, and downwards as it is. Now this cancel, 2 sin x cos x is done. Minus 1 and minus 1, it will minus 2, and upon same is sin x minus cos x the whole square. And that is your, students, final answer. Very easy, but these expansions are big, that's why these are IMP questions. Now I will going 18th one. 18 also very interesting numericals. Question number 18. ddx of your data given, derivative asking sec x minus 1, downwards sec x plus 1. So that also I just showing that our division form in denominator square sec x plus 1, and simple going to your denominator factor sec x plus 1. Now denominator ddx of numerator minus now numerator ddx of denominator. Simple, apply u upon v rule. Yes, denominator numerator derivative minus numerator denominator derivative. Now apply that sec x plus 1 same, that derivative is sec x into tan x, or one derivative 0, this one minus here also same, sec x into tan x, and one derivative 0 upon as it is. Students, here I will try to common taking sec x and tan x in the both way. So you just common apply sec x into tan x, remaining are sec x plus 1, here minus sec x plus 1 upon sec x plus 1 the whole square. Indirectly students that much cancel. 1 and 1 exactly 2. So 2 into sec x into 10x upon sec x plus 1 whole square, and that's your answer students. Very easy. Now continue 19. In the 19th one, ddx of derivative asking to in the related of questions sin the n power x. It's very easy. So but here I will check to by chain rule students. Yes, you consider here that is a x, consider raised to n. So your derivative is n of sin raised to n minus 1x and ddx of sin x, same by the chain rule, and by chain rule wise I will show that answer. So n sin raised to n minus 1x, but sin derivative you know which is cos x, and over sum. Now question number 20 students, ddx of 20 also very interesting questions and IMP for exam. So you will tick mark in IMP. A plus b sin x, a plus b sin x upon c plus d cos x. One more time check, c plus d cos x and a plus b sin x. Apply u by v rule in the denominator square very easily. C plus d cos x square, that's my denominator square, u by v rule. Now c plus d cos x ddx of numerator, a plus b sin x, it is denominator numerator derivative minus numerator denominator derivative ddx of c plus d cos x, and you will start your value c plus d cos x same. Here a derivative is 0, but b sin x is b same as per sin derivative, absolutely cos x, minus a plus b sin x same, but here c derivative is 0 because constant, and d cos derivative is a minus sign. I will show outside minus here, and upon c plus d cos x the whole square. Now I will expand totally in the numerator and you will get easily answer. So students, one by one I just show in the parts of simple to simple your multiplicative rule. So that multiply first bc cos x, bc cos x plus bd cos square x, bd cos square x. Now that minus minus plus ad sin x, and next minus minus plus bd b into d sin square x, and downwards students as it is c plus d cos x the whole square, because that this minus and this minus totally plus. Now look at that, this bd sin square x and bd cos square x I will take common. So bc cos x same, ad sin same, and bd common, just only cos square x plus you will show sin square x, and downwards as it is c plus d cos x the whole square. Now students, that much you know, it is exactly 1. So finally my answer bc cos x plus ad sin x plus bd into 1 by c plus d cos x the whole square, and that's your finally answer students. Now question number 21 is also same as I going running here students. Question number 21, it's very easy. ddx of sin x plus a by further given that cos x. So it's very easy. First of all, you apply the formula to numerators. Sin x cos a plus cos x sin a. And downwards cos x is as it is. And just you make the separations, you will get simple to simple answer. So does here I separation, one of the that divided and secondly that divided in the two partitions. And then after you will go to answer. Otherwise you also operate direct our division working rule. Both way correct answer. So it is sin x cos a by cos x, and secondly cos x sin a by cos x. So does that cancel? It will to cover tan x. So d dx my answer, tan x into cos a, and here sin a, it is a constant and constant derivative 0. So here cos a first, d dx of tan x and d dx of sin a. Now students, sin a derivative constant 0 and tan derivative you know that it is sec square x, here 0. In short my answer is a cos a into sec square x, and that's your finally, and students easily your answer is done here. Now students continue, we going ahead. 22. In the 22 question is yes, x raised to 4 y is given. So question 22, d dx of x raised to 4 into one of the given 5 sin x minus 3 cos x. One more time repeat, x raised to 4 5 sin minus 3 cos x. So does here that is u, but that is v. Apply u into v rule. So first second derivative 5 sin x minus 3 cos x. It is first second derivative. Now second first derivative d dx of just only you will show x raised to 4. Now simple, apply the rule. That the first rule is x raised to 4 same. Here 5 sin derivative is cos x. Here cos derivative minus sin, already minus here. I will show in the first sign. Now second 5 sin minus 3 cos x. That derivative is a 4 x raised to 4 minus 1. It is 3. So does here 4x cube. Can I write down this is a x cube into x? Common taking x raised to cube. Remaining are 5x cos x plus 3x sin x. And here only 4 multiply that, 20 sin x minus 12 cos x. Fourth is a 12. And that's your finally answer, students. Now continue question number 23. d dx of similarly going x square plus 1 cos x into cos x. So does that consider u, that we apply product rule. So first d dx of second, now second d dx of first, and start to rule for in the way of derivative. So x square plus 1 same, students, cos derivative minus sin x. Similarly here x square plus 1, x square derivative is a 2x, but 1 derivative is 0. That the final answer minus sin x same, x square plus 1, and here students twice x with cos x, and that is your finally answer. Now continue question number 24. Same way running. In the 24 d dx of question is 24, also very easy, ax square plus sin x into ax square plus sin x, and second p plus q cos x. Yes, ax square plus sin x, second p plus q cos x. Here also you will operate both product rule, u into v rule. So first, second derivative d dx of p plus q cos x. Now plus second, first derivative. Second is a p plus q cos x d dx of ax square plus sin x. Now you will show simple your value formula operate. So ax square plus sin x, same students, and here p is a constant, 0, plus q and cos derivative, known that minus sign. So here cos derivative is a minus sin x, plus secondly as it is p plus q cos x, here twice ax, and sin derivative students only and only cos x. That is your final answer. Only I just rearrange my data and we get the answer for your ax square with q sin x, same as sin square x. Similarly students, here q your cos square x, and further explanations in the same way either you will write down is same as your answers. So students, your answer is finally write down minus q sin x as it is ax square plus sin x, and second data also same, p plus q cos x with twice ax plus cos x, and that become our last one. Now continue question 24. d dx of now 25, sorry students, in the 25th questions, x plus cos x minus tan, x plus cos x, and second x minus tan x, x plus cos x, x minus tan x, apply product rule. So one of the first product, very easy, x plus cos x d dx of x minus tan x is first second derivative. Now continue plus second d dx of x plus cos x, and you will start product rule. So x plus cos x same, here derivative 1, but tan derivative students x square x and x minus tan x as it is. Here x is 1, but cos derivative minus sin x, and that's your finally answer. No more calculate. Yes, either you calculate, if you then 1 plus tan square x square x, x square minus 1 tan square x. Now question number 26, if you converting in tan, otherwise that finished. 26 also IMP questions, most IMP. d dx of 2 parts given, one of the 4x plus 5 sin x upon 4x plus 5 sin x upon 3x plus 7 cos x, 3x plus 7 cos x. Students, just I check my questions. 4x plus 5 sin x upon 3x plus 7 cos x, going to again division rule. In the division form, u by v rule, 3x plus 7 cos x the whole square. Now 3x plus 7 cos x denominator d dx of numerator, means u by v rule, denominator square, denominator, now numerator derivative minus numerator denominator derivative d dx of 3x plus 7 cos x, means u v derivative, now v d derivative. Now calculate the answers, very easy. 3x plus 7 cos x, this is the big expansion, 4 x derivative 1, 5 sin derivative cos x, minus 4x plus 5 sin x, same. This derivative, 3x is 3, x is 1. And here minus sign, cos derivative is a minus sin x. And downwards is same as students. What's your downwards? 3x plus 7 cos x the whole square. Now I will turn to expansion in the whole square. That you know very well. So this expansion I multiply. Here also that expansion multiply. So my first expansion is a 4th is a 12x plus 15x cos x. Continue now. 7 4 is 28 cos x. 7 4 is 28 cos x plus 35. 7 5 is 35 cos square x. This expansion done. Now turn to that minus 12x. 4 3 is minus minus plus 7 4 is 28 x sin x. Now turn to minus n plus minus 15 sin x. And last minus minus plus 7 5 is 35 sin square x. And upon as usual 3x plus 7 cos x the whole square. Students, one more time I just check. Minus, then after plus, minus, and last of the plus. That if you combine, it will show to 1. Sin square cos square is 1, 35 is common. And another this cancel. Your answer is 15x cos x, 28 cos x plus 28x sin x minus 15 sin x. And 35 common, remaining you have to cos square x plus sin square x, and downwards as it is 3x plus 7 cos x the whole square, and that I telling that it is 1. So my answer is 15x cos x, 28 cos x, 28x sin x minus 15 sin x plus 35 into 1 upon as it is 3x plus 7 cos x the whole square. Otherwise you will common taking here 15 common and here 20. Okay? It will be same answer, don't worry. Now continue. What is 7? Same way running. Question number 27. ddx of, in the same way going, x square cos pi by 4 upon sin x. X square by cos pi by 4 sin x. So here students, cos pi by 4 outside because constant, and remaining are as it is cos square x square by sin x. So it is here I will start my division rule in the solutions. So students, in the division form, here u by v rule operate. In denominator square, now denominator ddx of numerator minus numerator ddx of denominator. So your answer is very easy. Sin x same, x square derivative is 2x, and x square sin derivative is cos x by sin square x as it is. The numerical done, but only I take common the x. Cos pi by 4 constant. This x and this x common. There are 2 sin x minus x cos x upon sin square x. And very easily your answers. Now 28. Also same concept. Yes, 28 also same way going. ddx of x upon 1 plus 10x. One more time check, x upon 1 plus 10x students. So here also same concept, u by v rule, division form, 1 plus 10x the whole square Now denominator d dx of numerator minus numerator d dx of denominator n. Show the answer. So 1 plus 10x same. X derivative respect to x 1 only, minus here 0, but 10 derivative is a sec square x. Yes, and denominator are same is, so your answer is 1 plus 10x minus x sec square x upon, as it is. That much your answer, students, very easily. Now continue. Question number 29. Very interesting numerical, students. Only working rule apply and you will get answer. d dx of in the 29. My question is x plus sec x into, in second bracket given x plus sec x and second x minus 10x. So simple going, you have the value for product rule is u, that v, x plus sec x first d dx of x minus 10x first second derivative plus second first derivative x plus sec x. Now formula is very easily x plus sec x as it is. Here x derivative is 1, but 10 derivative is sec square x. Another as it is. Here 1 x derivative, but sec derivative is students sec x into 10x. Now simple over here. Now 30 d dx of, but 30 questions. Yes, 30 is the most IMP questions. You tick mark in the IMP list. X below. Your question is sin raised to n x dx. So this is an IMP question because here working rule apply as well as also chain rule apply. Then your numerical is done. That's why this numerical IMP questions. First I apply working rule, division rule. In the denominator square, sin raised to nx the whole square. Now denominator d dx of numerator minus numerator d dx of denominator. Now apply the formula. So sin raised to nx same, this derivative is 1, but here x, that is power at n first, you consider x raised to n. So n sin raised to n minus 1x and d dx of sin x as it is, and upon here I will write down sin raised to n into 2, it is 2n. So in short your data is sin raised to nx minus nx sin raised to n minus 1x. Here derivative cos x only, and upon as usual sin raised to 2nx dx. Now students, you will take the common. Yes, this power it is a common in this both part. So sin raised to n minus 1x common. Your remaining data only sin x raised to 1, because these same power additions you will get n, and here nx into cos x upon sin raised to 2nx dx. Finally, last step, these two are like term, base same, power subtractions. So sin x minus nx cos x upon sin raised to 2n minus n plus 1x. So it should be sin x same, nx cos x, and upon sin raised to n minus n means here n plus 1x Actually 2n minus 1 is n, and here minus 1 converting into plus 1. Yes students, here our sin x minus nx cos x by sin raised to n plus 1x is easily over. And here students, our exercise 13, these questions and this chapter also students ending here, and I will stop this video. Further explanation students in the new parts, for the new video I will explain in the next parts. Okay, bye bye.